Jojoba decides to take up javelin throwing. So she's throwing a javelin off a cliff. It's given by that function. Look at that function. It's a quadratic. That should make sense because when you toss something in the air, then due to gravity, after a while, it comes back down. So it follows that nice arch. Notice our A is negative. It's negative 16, which should make sense because when you toss something in the air, should it go back up and float forever? That'd be terrible. That means we lost all gravity and we're spinning out of control. We don't want that. We have 3 questions. Question 1, at what time does the javelin reach its highest height? Let's dissect that question. By asking for at what time, what variable are we solving for? For t. T works like our letter x. It's just a different letter t. By asking for what time is at the highest height, well, that corresponds to what special point on our graph? The vertex. Since our function is an ABC format, and we're looking for the vertex, namely the x-coordinate of the vertex, what formula are we going to use? Since we're in ABC format. Negative b over 2a. So for the first question, to find t, we're going to use the formula negative b over 2a. So we're going to have negative 33 over 2 times negative 16. Well, that's 33. Careful, the double negatives will make a positive. Is that okay? 33 over 32. If you want, a mixed fraction is okay here because this is a word problem. So 1 and 1/32 of a second. So in just over 1 second, the javelin reaches its highest height. And the second question is, what is the highest height? So by asking what is the highest height, what variable are we looking for? H. We're looking for h when t equals 1 and 1/32. So we're going to put in 33 30-seconds in for t. For this one, you are, oh, I forgot my coefficient. You are welcome to use a calculator. Because if you know how to do this in your head, you're in the wrong class. But that was all the rage up until medieval times. Let's go. Actually, the decimals aren't that bad. We can give the exact answer because it terminates. 65.015625. What's the unit here? Now the test, if this were on a test, I will tell you how far to round. Also in your homework, it'll tell you how far to go. All of the word problems in this section deal with the vertex. Anytime you're trying to maximize or minimize a quadratic function, that's saying, where's the vertex? So if your cost function, for instance, was a quadratic and you're trying to minimize cost, translate, that means find the vertex. If your profit function was a quadratic function, you're trying to maximize profit, find the vertex. Third question, when does it hit the ground? When something hits the ground, what is its height off the ground? 0. So instead of h of t, we're going to have 0. And by asking the word when, what letter are we solving for? T. Oh, I'm sorry. Did I say we solving for? I meant to say you solving for. If you would, solve for t. Let's see how you're doing. So we'll say t is equal to negative 33 plus or minus the square root of 33 squared minus 4 times negative 16 times 48 all over 2 times negative 16. Let's clean up that radicand and that denominator, and then we're going to throw it into the calculator. I'm sorry. 41, 46. The denominator is negative 32. Can I reduce those negatives? Nope. Leave it alone. All right. Let me show you how to put it into the calculator. All right. So if we're going to do this in one fell swoop, parentheses, negative 32, you have to do the plus and then the minus. So this parenthesis stops the radical. This parenthesis stops the numerator divided by negative 32. That number solves the equation but doesn't make sense for our problem. Can time be negative? No. So we don't want this one. So let's try the one with the minus square root. On your calculator, if you have an 8384, to get back the previous line, if you hit second enter, it copies it. Fancy. And then instead of that plus sign, just change it to a minus. Oh gosh, I went too far. Oh my gosh. Minus. 3.047. Does 3.047 make sense? Yeah. So just over 3 seconds, the javelin will hit the ground.